This is my experiment, the effect of ultraviolet light exposure on Escherichia coli at varying durations. Here's the introduction and rationale. Many bacteria and viruses cause illness and can be found on the surfaces of commonly used items. These items could be countertops, phones, and steering wheels. Essentially, things that we touch or come in contact with often. At the beginning of the pandemic, a new way of disinfection burst in popularity, which was the UVC light wand. This must be noted that UVC light has been used by scientists and medical professionals in the past, but now the general population has become much more interested in it. After hovering a UVC light wand over a surface for a mere 30 seconds, it should supposedly get rid of all surface bacteria. However, since this device is a newer and therefore less known about method of cleaning, it is unknown how long it should be used for. The rationale of this experiment is to test which duration of exposure to UV light is best at inhibiting the growth of Escherichia coli, or E. coli for short. This study is important scientifically, but can also be applied to real-life situations. Here is the hypothesis and research question. The question asked before this experiment was conducted was, what is the minimum amount of UV light exposure needed to kill colonies of E. coli? And then the hypothesis was formed. It was thought that if E. coli is exposed to UVC light for a minimum amount of 60 seconds, then the growth of bacteria will be prevented, because UV, or UVC light in specific, is a bactericidal disinfectant. Here are the materials that were used in the experiment. A UVC light wand was used, and it had a wavelength of 264 nanometers, meaning that it should inhibit bacterial growth since it is in the bactericidal UVC range. A non-pathogenic E. coli broth was used, as well as pre-poured agar plates, and a biohazard waste bag to dispose of all contaminated materials at the end of the experimentation. This is the methodology that was used in the experiment. After all materials were gathered and protective equipment applied, the agar plates were swabbed to the E. coli using the zigzag method, which is when you turn the plate about 60 degrees after swabbing in a zigzag motion for 3 times. After all plates were swabbed, half of each plate was covered using an index card and the visible portion was exposed to the UV light. After left for 48 hours to allow incubation, the growth was observed and quantified using a self-devised scale. All contaminated materials were disposed of in a biohazard waste bag at the end of the experiment, which was delivered to a biomedical waste company. Here's the data collected, which was then put into a bar graph as well as a table. The data is self-explanatory, but allow me to clarify the numbers in the graph and the table. A number 1 represents less bacterial growth than the control, a number 2 represents the same amount as the control, and a number 3 represents more bacterial growth than the control. This scale was created in order to quantify the growth due to the varying sizes and numbers of colonies on each plate. Overall, the agar plates exposed to the UV light grew more bacteria than the control group. This could be seen through the majority of the trials. Once again, the bacterial colonies were counted using the self-devised scale. This is interpretation. The hypothesis was unexpectedly disproven, which could have been due to the UV light lamp. The UVC light device did emit heat and was held relatively close to the agar plates. Since heat helps bacteria grow faster, it was thought that the UV wand helped promote the growth of the E. coli. Also, it should be mentioned that since the scale used to quantify the number of bacterial colonies was based on sight, there was possibility for human error. In the project, a handheld UV light device was used, but in another experiment, a lab-quality UV lamp could have been used to simulate what a scientist or medical professional would have access to, as opposed to the average person. This experiment teaches that not all UVC light devices will inhibit the growth of surface bacteria, which is important to know, since many people believe that they do work, even though they may not. Until a highly effective UVC light wand comes out, it might be safer to stick with disinfectant wipes and sprays. Conclusion. The UVC light was ineffective in slowing the growth of the E. coli, disproving the hypothesis. After some thought, it was believed that the UV light's emitted heat helped the bacteria grow faster. For reference, here are the websites used to conduct the research before the experimentation. I hope you enjoyed the presentation, and thank you for your time.